Alright, this is Algebra 1, Lesson 33. Products of prime factors, statements about unequal quantities. Alright, so prime numbers. I'm sure you guys have done this before. It is super duper easy. The book tells us one way to do it. I'm going to tell you guys the easy way to do it. I like factor trees. So, when we're talking about prime numbers, that's going to be a number that only has itself and 1 as a factor. So 1's a prime. We can't divide that into factors of other numbers. 2 is a prime. 3 is a prime number. No factors multiply together to make 3. 4 is not a prime because we can say 4, we can divide that into 2 times 2 makes 4. So 4 is a composite number. That means that we can multiply two numbers together other than 1 in itself, and we can come up with 4. So 4 is a composite number. 5 is a prime. 6 is a composite because we can break 6 down into 2 times 3 makes 6. 7 is a prime number. 8 we can break down into 2 times 4, and then we can break those down into 2 times 2. So 8 is a composite, and you can keep going like that. I think the next one is 9 is composite because it's 3 times 3. 10 would be 5 times 2. 11 is our next prime. So your prime numbers are ones that you cannot break down into factors. Your composites, you can break them into factors. All right. So 33.1 asks us to break 80 into its prime factors. So it wants us to tell them all the factors of the number 80. And it has you divide it by a bunch of different stuff. I'm going to just do it the good old-fashioned way with a factor tree. Okay? So I just need to think of two numbers that I can multiply together to get 80. I could say 40 times 2. 2 is a prime, so I'm going to go ahead and circle him. Now I'm going to break my 40 down, and I could say that is 20 times 2. 2 is a prime, I'll circle him. Then I can break that down into 10 times 2. Circle him, and my 10 could be 5 times 2. And then I can't break them down anymore, so 80's primes are going to be equal to 2 times 2 times 2 times 2 times 5. So 1, 2, 3, 4 2's. Actually, I don't need a comma. What I need is a multiplication sign. 1, 2, 3, 4 times 5. Okay, that's a factor tree. I could have done it a different way. I could have said, all right, I know that, let's say, 10 times 8 is 80. All right, now I can break my 10 into 5 times 2. That's all I got for that one. And then my 8 I could break into 4 times 2. And then my 4 breaks down into 2 times 2. And you'll notice I still get the same 2 times 2 times 2 times 2 times 5. So it doesn't matter what numbers you pick when you do the factor tree method. There's another method that is just like the factor tree method, but it's a little neater. So we're going to draw a line under it, and we're going to divide by 2. And we would end up with 40. And then we draw a little line under that, and we divide by 2 again, and we end up with 20. And a little line under that, and we divide by 2 again, and we end up with 10. And a little line under that, we divide by 2, and we end up with 5. And then all of our factors are just sticking out here to the side. Just don't forget to get that bottom one. So all the ones on the side and the bottom are going to be your factors. Okay? If it won't divide by 2, then you try 3. If it won't divide by 3, then you try 5. So you just keep going up your primes. Those are good for bigger numbers. All right. Let's try another one of those. I don't have one, but I'm going to try 150. Okay, so if I tried my little divide by 2 method, if I divided that by 2, I would get 75. Now I can't divide by 2. Can I divide by 3? Yes, I can. 3 times 25. Now can I divide that one by 3? No, but I could divide by 5, and that's 5 times 5. So my factors are 2 times 3 times 5 times 5. That's how you do it with the little drop-down method. If we used a factor tree, we could do the same thing. If I was using a factor tree, I might say, I know that that is, let's see, there's 4 quarters in a dollar. That's going to be 6 quarters. That's 6 times 25. Do that first. And then my 6, I could say that's 2 times 3. And those are primes, so I don't have to go any further. My 25 is 5 times 5. And those are primes. And I still get 2 times 3 times 5 times 5, same as if I use the drop-down method. So either way works the same. All right, the next part of the lesson is statements about unequal quantities. So these are going to be the ones where you have to read the stuff out and you have to make it into an algebra problem. But on these ones, they're going to tell you about quantities that are not equal. So in 33.3, we have twice a number in 42. So twice a number and 42. Oh, whoops, no, not twice the number and 42. Twice the number is 42 less than negative 102. Find the number. Okay, so what I'm going to do first is I'm going to write a statement that's not true. I'm going to write 2n for my twice a number, and then I'm going to write my equal sign, and then I'm going to write my negative 102. Okay, so I've used that. I still need is 42 less. Okay, so I got a negative 42 is going to have to go somewhere. This is saying that twice the number is 42 less. So this side is 42 less than this side. So to fix that, I can subtract 42 from this side, or I could add 42 to that side. Okay, so twice the number is 42 less than 102. Okay, we're going to try it this way. So we got 2n equals, now we're going to say negative 102, negative 42, that's going to be negative 144, and then we're going to divide by 2, and we get n equals, what's half of 144? Negative 72. 7 and 7 is 14, 2 and 2 is 4, yep. So there's that one. So you're just going to write it out, and then you're going to figure out where that less goes. All right, let's try another one. 33.4. 5 times the number is 72 greater than the opposite of the number. Alright, so 5 times the number, that's going to be 5n, is 72 greater. Okay, so I use that. Then the opposite of the number, so that's going to be negative n. Okay, now I got to figure out where the 72 greater goes. 5 times n is 72 more than whatever this is. So if I add 72 on this side, then they're going to be equal. Does that make sense? So this side was 72 more, so I had to add 72 on this side to make them equal. Now I can solve. So plus n and I'm going to get 6n equals 72, and then I'm going to divide by 6, and that's going to be n equals, if we know our 12 times tables, that's 12. 72 divided by 6. Alright, so they're a little bit tricky. You just have to think about them a little harder than the other ones. Alright, let's try 33.5. If the sum of twice a number and negative 14, so we got sum, twice, n, and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number. Okay, So we got the sum of twice the number and 14. So 2n minus 14. Okay, so the sum of twice the number and negative 14 is multiplied by 2. So this whole thing has to be multiplied by 2. The sum of twice the number and negative 14 multiplied by 2. The result is 12 greater than the opposite of the number. The opposite of the number will be negative n. So it's saying that the result of all this, so this part's result, is 12 greater than this. So we've got to add 12 on this side to make it even. This is 12 more than that. So we add 12 here to even it out. Alright, now we can solve by, first we rainbow. 2 times 2 is 4n. And then 2 times 14 would be negative 28 equals negative n plus 12. And then we're going to add 28. And we're going to get 4n equals negative n plus 40. And then we're going to do plus n. And we're going to get 5n equals 40. And then that would be divided by 5. And we get n equals 8 times 5 is 40. And equals 8 on that one. Okay? So they're a little tricky. Just make sure that you're paying attention to where it's saying something's greater than something else. Alright, one more. 5 times the number is 21 less. So 5 times a number. And when you're doing these problems, you do not have to write them down. Like, write out the words. You can just write the equation. I'm just writing the words so that I can make sure that you guys understand it. Then twice the opposite of the number. Then okay, so 5 times the number, that'd be 5n, is 21 less than twice the opposite of the number. So I'm going to write twice the opposite of the number is that. Now I got to figure out where this 21 less goes. So it's saying this is 21 less than this. So I'm going to add 21 to make them even. If this side was 21 less than this side, you just add 21 over here and it fixes it right up. Or you could have done minus 21 over here. Either way works. Alright, now I just got to solve. So I'm going to do minus 5n on this side. And I'm going to get 21 equals negative 7n. And now I'm going to divide by negative 7. And I'm going to get n equals negative 3. Alright, hope that made sense to everybody. Pause the video and do the practice problems, and then I will come back and work them for you. Alright, we're going to start with A. And A says, find a number such that 8 times the number, so that's going to be 8n, is 36 greater than the opposite of the number. I'm going to do my opposite of a number. That would be negative n. Okay? And it says this side, 8 times the number, is 36 greater than this side. So if I add 36 on this side, then they're going to be even. Alright, now I'm going to subtract n, add n on both sides. Cancel. That'll be 9n equals 36. And then I'm going to divide by 9. And I get n equals 4. 9 times 4 is 36. So that one's 4. Okay. Now I'm going to do B. B says if the sum of a number and 6 is multiplied by 2, so the sum of the number and 6 is multiplied by 2, okay, sum of number and 6 and multiply that by 2, the result is 10 greater than the number, okay. This is 10 greater than this, so if I add 10 over here, then they're even, okay. I could have subtracted 10 from that side, but for me it's easier to just add it over here. So the result of this, so it says the sum of a number and 6, is multiplied by 2. Its result is 10 greater than the number. So I added 10 over here to make them even. All right, now I'm going to distribute, so I'm going to get 2n, and then 2 times 6 is 12 equals n plus 10. Now I am going to get my n's together, and I'm going to get 1n right here plus 12 equals 10, and then I'm going to subtract 12, and I'm going to get n equals negative 2. Yep, n equals negative 2. So easy peasy on those. In the examples, they always give you really hard ones, and then your actual problems usually aren't that hard. All right, so C wants us to factor 108 into prime factors. 108. So I'm just going to do a factor tree on this one. Actually, I'm going to do the drop-down method. I'm going to divide that by 2. And I'm going to get half of 100 is 50, half of 8 is 4, so 54. And then I'll just divide by 2 again. Half of 50 will be 25, half of 4 is 2, so 27. Okay, I can't divide by 2 anymore, but I can divide by 3. 3 times 9 is 27. And I can divide that one by 3, and I get 3. So I should have 2, 2, 3, 3, 3. So you have 2 2's and 3 3's. Yep, there's that one. D gives us the number 400, and it wants the factors of that. So 400, I think I'm going to do that one as a factor tree, and I'm going to say that would be 100 times 4. That's the easiest one I can think of. And that could be 50 times 2. And 4 is going to be 2 times 2. I could circle all my 2's. Now I just got to keep breaking down this 50. I could do 5 times 10. My 5's a prime, and then my 10 could be 2 times 5. Go. So I've got 1, 2, 3, 4 2's. And 2 5's. And that is that. So you could do it either way with the factor tree or the little drop down method. Either way is fine. Alright, so the homework is lesson 33. I will see you guys on Wednesday.